Okay, today we're going to be factoring trinomials when a is not equal to 1. This is going to be grouping and bottoms up method. So for today, we're only going to be focused on the grouping method. And basically, you're going to use this method when your first term is not 1. So it doesn't look like x squared plus 7x plus 8 because there's a number in front of the x squared. Step 1 is always, always, always look to factor out the GCF first if possible. And if you can't factor out the GCF and it's not equal to 1, um, you have two options. You can either use the grouping method, or you can use the bottoms up method. And again, this first video will only take care of the grouping method. Okay, so factoring by grouping steps, when it's ax squared plus bx plus c, you're going to use the x method to find your m and n. So basically, you're gonna start off exactly the same, and you're going to find two numbers. I'm going to call that first number m, and the second number n. And I'm just going to go ahead and highlight these numbers just so it's a little bit easier to kind of reference back once we do this. Once you have that ready, then we're going to go ahead and we're going to rewrite the ax squared plus bx plus c. But this time, instead of it looking like this, you're going to replace the b. So notice that these two are exactly the same. And these two are exactly the same. But this middle number, the bx, we're going to change to mx and nx. Basically, you're going to take your m, which is the green number you just found. And you're going to take your n, which is your pink number that you just found. You're going to replace the middle one with those two numbers. Then you're going to factor out the GCF of ax squared plus mx, and then separately the nx plus c. So the first two, you're going to factor out the GCF. The second two, you're going to factor out the GCF into this and this. And then if you did it correctly, then you should be able to factor out what you just factored out. And I know that sounds very, very weird. That was step 4, but we're just going to go ahead and show you how that works. All right, so let's just jump into it. I got 3x squared plus 10x plus 8. Um, again, you look for a GCF. There is no GCF. So I'm going to jump in straight into using my x. Remember that to get the top number, you're going to multiply your a and your c, which means I'm going to multiply the 3 and the 8, which gives me 24. And we need to add up to the middle number, which is 10. Okay, so I'm going to make my list. What numbers multiply to 24 and add up to 10? So 1 and 24, 2 and 12. 2 and 12 looks like it's going to work if it was a -2, because -2 plus 12 gives me 10. But -2 times 12 gives me a positive 24. I'm sorry, -2 times 12 gives me a negative 24, and we're trying to get a positive 24. So that actually doesn't work. So let's keep going. 3, 8, 4, and 6. And 4 and 6 is the one that's going to work. So I can go ahead and stop my list and say it's got to be 4 and 6. Now, this is my m. This is my n. So now that I did step 1, I'm going to go to step 2, which is to rewrite ax squared plus bx plus c. But instead of using this b, I'm going to use these two numbers instead. So the first number is going to stay the same. It's still going to say 3x squared. Instead of the 10x, I'm going to use these two numbers. So let me write it. This is going to be plus 4x plus 6x. How did I know it was 4x? Well, because that's my green number, my m. How did I know it was 6x? Well, that's because that's my pink number, my n. And I want you to notice that this 10x, it's still 10x. It's just that the 10x is written differently, okay? It's still 10x. And then instead of that plus 8 at the end, I'm just going to go ahead and bring it down. So step 2 is done. Those two statements are exactly the same. Now I'm going to go to step 3. I'm going to factor out the GCF from the first two terms, factor out the GCF from the second two terms. So here are my first two terms. I'm going to factor out the GCF. Between 3 and 4, it's 1, so I'm not going to write it. Between x squared and x, it's x. So actually, the GCF between those two is just the number or the variable x. How do I get it back? Well, I'd have to go x times something gives me 3x squared, and that something must be 3x. X times something must give me 4x, and that must be 4. Okay, this next part, whatever symbol is here, you need to bring that down automatically. So this is going to be a plus. And then I'm going to go ahead and factor out the GCF between the next two terms. The GCF between 6 and 8 is 2, and they don't share any x's. So I'm going to write 2 parentheses. Okay, now I need to get it back. 2 times what is going to give me a 6x? That would be a 3x. And then 2 times what is going to give me a positive 8? That would be a positive 4. So step 3 is done. I factored out the GCF from my last two terms. And then step 4 is I'm going to factor out the common polynomial. I'm going to factor out what I just factored out. If you did this correctly and if it factors, then you should end up with the exact same thing inside both parentheses. If that happens, you know you're doing this right. So you see how the first part has a 3x plus 4 and the second part has a 3x plus 4? I'm going to factor that out. That means I'm going to pull out the 3x plus 4 from both of them. If I had this and I pulled away the 3x plus 4, what I would be left with is just the x. And if I had this and I pulled away the 3x plus 4, what I'd be left with is just the 2. And that's how this thing factors. And we're done, okay? We can really quickly check this to make sure that this actually works. 3 times x is 3x squared. 3x times 2 is 6x. 4 times x is 4x. If I get a 6x and I combine it with a 4x, that is going to give me the 10x. And then 4 times 2 gives me the 8. So this absolutely does work, okay? And that's the last time I'm going to check it. I'll leave the checks up to you. All right. So I understand that that process might have been kind of weird. So we're going to run through it again. Again, notice that right here, my a is not equal to 1. I'm going to look for a GCF. Hopefully that fixes that, but it doesn't because there is no GCF between all three terms. So I'm just going to go ahead and start jumping into making my x. Remember, to get the top number, you need to multiply AC. So 5 times 2 gives me a 10 on the top. And then they need to add up to 7. So let's quickly make a list. 1 and 10 doesn't work. 2 and 5 absolutely works. So I'm going to stop my list right there. I know that it's 2 and 5. This is going to be my M. This is going to be my N. Now that I have this, I'm done with step 1. I use my X to find my M and an N. I'm going to use step 2. I'm going to rewrite this function, but instead of writing it like this, I'm going to replace the middle term. Instead of 7n, I'm going to replace it with these two. So this is still going to be 5n squared. Instead of 7n, I'm going to write it as plus 2n and plus 5n, and then I'm going to bring down the plus 2. Remember that the 5 came from my pink number, the 2 came from my green number, and that I still have the exact same thing as before. 7n is still right here. It's just written a little bit differently. So step 2 is done. I rewrote it. Step 3, I'm going to factor out the GCF from the first two terms and factor out the GCF from the last two terms. I'm going to factor out the GCF from these two. What's the GCF here? It's n. How do I get it back? I get it back with a 5n and a plus 2 because n times 5n is 5n squared and n times 2 is 10n. So this actually does work. At this point, whatever symbol you have here, you need to bring that down immediately. And here's where it gets a little weird. Let's see, what's the GCF between 5n and 2? The GCF is 1. Now, normally I would say if the GCF is 1, just leave it alone, don't write anything, right? But here you absolutely do need to write down the 1 because I need stuff in parentheses, right? So how do I get this back? Well, I just multiply 1 times 5n and 1 times 2. Okay, if I did this correctly, then these should match, and they absolutely do match. I have a 5n plus 2 here and a 5n plus 2 here, which means that's the thing that I'm going to factor out from both of them. I'm going to pull away that 5n plus 2, and what am I left with? I'm left with an n, and I'm left with a plus 1. So in my parentheses, I'm going to go an n plus 1. I don't think I did a good job of explaining why that works. If I were to distribute the 5n plus 2, that would be an n times 5n plus 2, which is what I have here. And if I distribute it over here, that would be a 1 times 5n plus 2, and that's exactly what I have there. So all I'm doing is I'm factoring out the 5n plus 2 from each one of those terms. All right, a couple of things here. Be careful with this one. On this one, the first thing I notice is this is not written in the correct order. So right away, I need to write this in the correct order. This is going to be negative 12x squared minus 2x plus 24. Okay, now I can go ahead and start the problem. What's the first step every single time is look for a GCF. There is a GCF. In this case, the GCF is equal to negative 2 because it started with a negative. So let me factor out that negative 2. That's going to be negative 2 parentheses. What am I left with? I'm left with a positive 6x squared plus x minus 12. And again, that's just something that at this point you should be pretty comfortable with. All right, from here, now I can go ahead and notice that, oh man, I have a number that's not 1 there. So I'm going to have to go ahead and use my X method, but I got to use my X method using grouping. So let's go ahead and start writing that X. My new AC would be 6 and -12, which is a -72. And the middle number is 1. So I need numbers that multiply to -72 and add up to 1. So I'm going to write down a list, right? But I mean, guys, you got to start getting a little bit smarter with your list too. Like if I how do I get two numbers that add up to 1? Well, that means those two numbers got to be really really close to each other. That way they kind of cancel a lot of out. So when I start my list and I say like 1 and 72, like obviously that's a horrible combination because those numbers are so far apart. Like when I combine the 1 and the 72, there's no way that's going to give me a 1. The numbers need to be really close to each other. And if you start thinking of it that way, I guarantee you some of you guys already know what numbers it should be to get to 72 that really close to each other and they multiply to 72, add up to 1. But I'm going to go ahead and go through the list later, or the long way, just so you can see in case you don't see them at all. So it's going to be 2 and 36, 3 and 24. Again, these numbers are really far apart. This is not working. 4 and, I can't think right now. There's 36, 18. 5 doesn't work. 6 does work. 6 works with a 12. 7 doesn't work. 8 does work with a 9. And look at how close those numbers are together. Remember what we said earlier? And this will work as long as the 8 is negative. So I'm going to write it as a -8 and 9. The other thing I want to stress is it didn't matter if you write -8 and 9 or if you wrote 9 and -8. As long as the numbers work, this process will still work. It doesn't matter if you flip the numbers backwards. Okay. All right, now that I have this, I'm going to go ahead and rewrite this. Remember, we have a -2 parentheses. Instead of writing it as 6x squared plus x minus 12, I'm going to use my green and pink numbers. That'll be this one and this one. All right, so what do I get? I get 6x squared minus 8x. You need to put the x's on your pink and green numbers plus 9x or else this is not going to work. And then a minus 12. Now that I have it like this, I can go ahead and factor the first two, factor the last two. All right, I'm going to write -2 parentheses. Let's see. Let's go ahead and factor out the 6x squared minus the 8x. The GCF there would be a 2 and an x. Make sure you factor out the greatest common factor or else this is not going to work. You absolutely need the 2 and the x. How do I get this back? 2x times what is going to give me that 6x squared? That would be a 3x. And then 2x times what is going to give me that -8x? That would be a minus 4. At this point, whatever symbol you see there, you need to bring that symbol down immediately. So that's going to be a plus. And then I'm going to factor out the GCF between the next one. The GCF and the next two is a 3. How do I get it back? 3 times 3x is going to give me the 9x. And 3 times -4 will give me the 12. Hey, be careful. You see how this parentheses matches up with this parentheses and this parentheses matches up with this parentheses? I am missing a parentheses, right? I'm missing this partner, which needs to go way over here. For those of you guys who are into coding, like you know how much trouble that'll give you if you don't match up your parentheses. All right, if I did this correctly, then there should be stuff that matches, and there absolutely is right here and right here. So let me go ahead and factor out that 3x minus 4. I know I'm doing this right because I saw something that matched. If I took away the 3x minus 4 from the first one, I'd have a 2x and a plus 3, so that's what I'm left over with. And if you write it like this, your answer would be wrong because, again, we still have that -2 in the front, so we need to bring it down. Okay, let's take a look at the next one. Again, we're going to write this down in the correct order. I should be writing this down as -24x squared minus 12x plus 9. I look for a GCF, and there is a GCF of -3. So I'm going to factor out GCF -3 times parentheses. What am I left with? Let's see. -3 times what gives me -24x squared? That would be an 8x squared plus 4x minus 3 to get the stuff up here. All right, again, notice that we have that 8 in the front. So this is going to be a little bit more work. We're going to use the grouping method. I'm going to go ahead and make my x. I'm going to multiply my AC. That would be 8 times negative 3, which is negative 24. And then my middle number is 4. So what multiplies to negative 24 and adds up to 4? I'm going to go ahead and start making my list. That's going to be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are all the things that multiply to 24, and 6 and 4. Take a look at those ones. Which one is going to make a combination of 4? And it looks like none of them work, right? None of these things are going to add up to 4. So then what? Well, that means that this thing right here cannot get factored anymore. So at this point, since you can't find a combination, and we listed them all out, then we are done. This would be the answer that you would type into the formative or whatever format that you'd be using. Okay, so that takes care of the grouping method overall for trinomials. Now, this is going to be really important. If you have a problem with 4 terms, and by the way, guys, this is going to finish out our notes, okay? If you have a problem with 4 terms in it, you have to try to factor by grouping. I'm not going to show you any other method other than you have to use grouping. So up until now, we've always had 3 terms: 1, 2, 3, 1, 2, 3. This one has 4 terms in it. In some cases, it does seem like it's going to be more complicated, but if you know how to factor with grouping, it actually becomes a little bit easier, because technically what this is saying is like you don't have to do an X, right? Like it's pretty much almost ready to go. You just have to follow the steps as before. Remember, first step always, always, always is to factor out the GCF. So I'm going to take a look at 2x cubed plus 8x squared minus 3x minus 12. There is no GCF. So now what? Well, normally I would start making my x, but this is not a trinomial. This is a polynomial, right? It has 4 terms in it. So you're just going to go ahead and start factoring 2 at a time. So let's go ahead and take out the GCF out of the first two. That would be a 2 that they share, and I can pull out 2 of those x's. So I'm going to write x squared. How do I get this back? Well, 2x squared times an x would be 2x cubed, and then 2x squared times a 4 would give me the 8x squared. Remember, at this point, whatever symbol is here, you need to bring down immediately. So I know I'm bringing down a negative. That's pretty much telling you that you're factoring out a negative something, okay? And what's the GCF between negative 3 and negative 12? Well, that would be a negative 3. So I'm going to factor out a negative 3. How do I get this back? Well, negative 3 times something gives me a negative 3x. That would have to be an x. And negative 3 times something gives me a negative 12. That would be a positive 4. And again, I know I did this correctly if something matches, and it sure does. I see an x plus 4 here. I see an x plus 4 here. I'm going to go ahead and factor out that x plus 4. What am I left with? I am left with a 2x squared from my first term and a minus 3 from the second one. And it looks like at that point we are done. All right, down to the last one. Again, I have something that has 4 terms in it, which means I should factor by grouping, and you're pretty much going to jump into the grouping, but first step always is to factor out a GCF. Is there a GCF between 4y cubed, negative 6y squared, 36y, and a negative 54? There is. It's 2. So let me go ahead and factor out that 2. To get all of this stuff back, I would need a 2y cubed, a negative 3y squared, a plus 18y, and a negative 27. All right, notice the stuff in the parentheses still has 4 terms in it, which means because the GCF is done, I'm just going to go ahead and start factoring by grouping. So I'm going to factor out the first 2 terms. Between 2 and 3, nothing really. Between y cubed and y squared, I can definitely pull out y squared. So 2 parentheses, I'm going to factor out the y squared, and now I need to get this stuff back. Y squared times what is going to give me a 2y cubed? I would need a 2y. And then y squared times what is going to give me a negative 3y squared? That would be a negative 3. Close my parentheses. Wherever I'm at right now, that symbol needs to drop down, which means I need to bring down a plus. And now I'm going to factor out the GCF between 18y and negative 27, which in this case would be the number 9. 9 times what is going to give me an 18y? That would be a 2y. 9 times what is going to give me a negative 27? That would be a negative 3. And again, guys, just be careful with your parentheses. Right now I have this parentheses and I have this parentheses. So those are my sets. But I also have this one and there's nothing closing it. So I need to close it over here. All right, did I do this correctly? I did. I know because I have the 2y minus 3 and the 2y minus 3 here. They match. So let me go ahead and factor that out. What am I left with? Well, I'm still left with a y squared plus 9. And if you leave it like this, it's going to be wrong because remember, we still have that GCF of 2 in the front that we factored out in the very beginning. Okay, that's all the notes for today. You will have a second part to these notes on the back side, so make sure you leave that free. But as for today, that is it. As always, if you have any questions, please feel free to ask.